Are you in a cylinder rut? If your brand of KIKs just aren't up to your standards, we have the solution. Once again, 𝗣𝗲𝗞 has stepped up to the plate and re-engineered the entire 𝗣𝗲𝗞𝗞's preferred line. We're going to take a look at the new generation of 𝗞𝗞's KIKs, and you'll thank your lucky stars that you did. Hi, this is William Lynk, and right now we're going to take a look at the 𝗣𝗞𝗞𝗞's preferred KIK cylinder, also known as a key and knob cylinder, or KIL, key and lever, or KID, key and deadbolt. It's a trio that works together. We're going to start out with the visuals. We're going to look at the similarities and the differences of these three KIKs, and that's what we're basically going to call them for the purposes of this training session, KIKs. We're going to look at the improvements, the old product versus the redesigned new 𝗣𝗞𝗞𝗞's preferred. Then we'll take a look at the components, which is very important. There's a table that shows how all the parts work together. Then we'll do the math, and it's simple math and easy to do. And then we'll put that math down on paper. We'll do the combinating setup. We will actually combinate by putting the pins in the cylinder, and then we will test to show the cylinder works beautifully. So the first thing we're going to do is show you the three different KIKs and what's similar and different about them. The first KIK is the 1099, which is the most common. What you can notice about this is that we have a large diameter plug head. I'll turn it to the side so you can see that. And on the back, we have a screw cap that's easily able to be removed and put back on. The second is the 1095. If you notice the plug head on this one, it is a smaller diameter, although the back of the 1095 has the screw cap on as well. And finally, the 1006, the plug head is large diameter or standard diameter, and the back, though, has a C-clip to hold it on. So those are all three of the ones that we're going to be using today. The shells now are made of brass, not nickel plated. The plug change for the 1006 large diameter is the same as in the 1099 and 1095. The bottom pins now all use the J bottom pin, including the 1006. As far as applications for these KIKs, the 1099, the most common, would be used for Arrow, Corbin Russwin, Master, Medico, Schlage, Falcon, LSDA, Mark, Sargent, and 𝗣𝗲𝗞. The 1095, Cal Royal, Weiser, Sargent, Falcon, Yale. And the 1006, Arrow, Weiser, Sargent, Master, and Trilogy. Now for the components, we have the spring retainer, which is new, the 8400. As far as control chambers, there are none in the KIK. The top pins, some of them may be split depending on the pin itself. And for the 𝗞𝗞's patent pins, we have a bottom pin that is already in the cylinder sub-assembled. You would just need to add the top pin, which is patented, and another pin, the 7B, in order to fill up that remaining space. What we need to do now is look at the components chart, which shows you all of these various components. Here we have the 𝗞𝗞's preferred component table. The beauty of this is that all of the parts that you're going to need are listed here, so you'll know exactly what you need to use. For the KIK, we have two lines. The top line is for the 1006 KIK and the parts, and the bottom is for the 1095, 1099 KIK. All the parts are basically the same with the exception of the retainer, either the C-clip or the screw-on cap. Before we combinate our cylinders, we always have to do our math first on paper. For this product, we have a pin stack total of 26. It's going to be a uniform pin stack, so all chambers will be exactly the same height. We're using an SFIC system, small format, and in this case A2. We can combine it to an A4 increment system, but A2 is the most common, and that's what we're going to use for our demonstration. Because this is based on an A2 system, we're going to combinate from the back of the core to the front, which is chamber 1 up through chamber 6. And the keys are red engaged the same way, from tip to bow. We first put our key biddings in our chart. Then we add in our bottom pins, calculate master pins and top pins, which is what I'm going to show you now. I've already done the math for you, but I'll show you how it is done. Okay, what we have here is our KIK coded pinning chart. It's already filled out. Now what we need to remember is our pin stack total will be 26, and we are dealing with a large diameter plug. The first thing we do is take our key biddings and we put them into the proper place. We start with the change key bidding on this line across. We have that in blue. This is our top master key, and for our entire system we have the control key bidding listed here. We won't have to worry about the control key for the KIK within our system. Below this black line we have our pins, sort of like an X-ray view of the cylinder itself. Our bottom pins are here, and we'll be using the J bottom pins, and the master and top pins, our wafer pins, will be the B top pins. Now, the first thing we do is we take a look at the two operating keys, the change key and the top master key. In order to find the bottom pin and master pin, it's basic locksmithing skills here. We're going to take the smaller number of the two. In this case, it's a 3. We put the 3 as our bottom pin. The difference between the 3 and the larger number becomes our master pin, and that is a 2. For the second chamber, we see of the two numbers, the 5 is the smaller number. We put that in as the bottom pin, and the difference up to 9 would be 4. And in our third chamber, our lower number is a 3. We put that as our bottom pin. The difference to our larger number is 4. We do that for the remaining chambers. That gives us our bottom pins and our master pins. Now, all that we have left to do is determine the top pins. Well, in a small format kit, some of the pins that we will need here are larger than what exists, so we simply split that pin, and we'll show you how it's done. Our pin stack must total 26. So, we see that on our plug right now we have 5. Well, we need to know what the remainder will be. Well, 26 pin stack total minus the 5 we have in the plug yields 21. So our top pin will be a 21. But there is no 21 top pin in a small format kit. Easy. You just take it and split it in half, or as close to half as you can get. In this case, a 10 and an 11 pin will work perfectly. So I put the 11 pin here, and in this box I put 10. That equals 21. In the second chamber, I look at our bottom pin and master pin. It equals 9. 26, our total pin stack, minus 9 yields 17. So our top pin is a 17, and you will find that in the small format kit. And in the third chamber, for example, our plug total is 7. 26 minus 7 gives us 19 left. There is a 19 top pin. Had there not been one in your kit, well, very simple. You take that 19 and split it in half as close as possible for 2 pins. We have an 18 pin in the fourth chamber, but we have 23 in the next chamber, so we break that down into an 11 pin and a 12 pin, as you see here. And then finally, in our last chamber, we have 26 minus 5 yields 21, and we can break that down to an 11 and a 10 pin. Now our math is complete, and we can go and combinate our KIK cylinder successfully. Let's take a look at the 𝗣𝗞𝗞 Preferred A2 Universal Pin Kit. The pin kit itself is set up so we have the bottom pins at this section. The J large diameter bottom pins are located here. The A bottom pins for other cylinders are located in this section. Our wafer pins, which would be top pins, build-up pins, also known as control pins, and master pins are in this section. Over to the left, we have spring retainers and more retainers on this side. We have patented bottom and top pins in here, as well as caps and springs. The next step is to take the pins and components that we need from the kit and put it onto a pin block or a pinning mat, whichever works good for you. If we look here, we see the bottom pins are 1 through 6. We have the master pins in a row, and then we have our top pins. Our springs are at the top. Over to the far right, we have our special chamber. Our bottom pin is empty in the block because it's already in the KIK. And that's because that's factory loaded and it's sealed. All you have to worry about putting in would be the patented top pin and an extra 7B on top of that to fill up the remaining space. Over here, we have the slide cover, which is newly designed for this particular cylinder. Now, the first step, I like to take something to stabilize my cylinder, and I did that right here so that the plug and the shell are aligned perfectly so the patented pins and the regular pins can fall in to the bottom of each chamber. Again, we're going to start from the very back, chamber 1. I'm going to take my bottom pin and I'm going to put it into the first chamber. Fell in beautifully. Now the master pin, those are a little tricky. There it is. Dropped in the master. I'm going to make sure those were loaded properly and even. The next step would be your top pins. Top pins are in. I'm just going to double check, make sure they're all level. There they are. Let's go on to the second chamber. Chamber number 2 from the back. Bottom pin fell in beautifully. Master pin is in. Seated beautifully. And now the top pin. Great. Now you continue the rest of the cylinder until all chambers, including the patented top pin chamber, are completely filled. What's important to notice is that all pin stacks are at uniform pin stack height. And visually you can tell that, and that means that we've combinated our cylinder correctly. The next step is to drop in your springs. With the springs in, we slide on the spring cover. We've already covered 4 chambers. We have 2 more to do. They're all covered, and the next step is to test our keys. We have a change key here. I'm going to put my hand just to hold the cover in place, and we're going to test the key. Beautiful. And now I'm going to do our master. Perfect. The last step is just to secure by a slight tap, just to push it down enough so that the spring cover stays in place. Now that we've secured the slide, we're going to do our final key test. Perfect. Smooth, excellent. So now we have successfully combinated and tested the 𝗣𝗞𝗞𝗀 Preferred 𝗤𝗘 cylinder.